This presentation will be on the mayfly abundance and diversity in Herring River. It was done by Megan Riley, Dom Derdarian, Kyle Massey-Charlton, and Richard Tenori.
The contents that we'll be going over in this project are the introduction, which will include information about mayflies, the purpose for project, sample collection location, which was the Herring River. We'll also go over methods and procedure, which will also include the equipment and materials, collection process, sample organization, and then we'll go over the results, which is the data we collected in the correlation.
Some information on Ephemeropta. These mayflies are found in a variety of locations, including rivers, streams, lakes, and wetlands. Specifically, flathead mayflies are most common in slow, fast-flowing streams where they occur on the surface of rocks, vegetation, and leaves. Mayflies begin their lives as an aquatic larvae, which they live in the water for about a year before they become a terrestrial adults. These adults only live 1 to 2 days and have no mouth, so they do not feed on anything, so they just reproduce before they die. Mayflies themselves are a really good indicator of water quality, along with being an excellent food source for some fish. They have adapted well to the swift-flowing waters, so their bodies and heads, along with their legs, have flattened, which reduces drag by the water forcing over the organism. Most of the flathead mayflies feed on algae and microorganisms that are growing on the rocks. Many of them have 3 tails, which you will see in the photo later on in the presentation.
The purpose of this project is that we'll be studying the life cycle of the mayfly. We have taken measurements of the size of the mayflies every week to see the correlation between time of year, water quality, and water temperature. The goal is to see if there is a relationship and if the relationship is positive or negative. This is a year-long project conducted every Tuesday. This project is a continuation of a similar project that was started last year by since graduated MSSEP majors. The previous project was stopped in March of 2020 due to COVID-19.
The sampling location that we chose to sample the flathead mayfly was the Herring River in Bourne, Massachusetts. This is a single direction flow man-made drainage basin from Herring Pond. If you look at the right, you can see a picture of Herring Pond, which is just above on this first picture, and the red dot is the sampling, and then a zoomed in photo of the river itself and the parking lot where we would sample. The river that drains Herring Pond flows directly into the Cape Cod Canal, and the site is located at the Herring River access point on Bourne-Dale Road.
The equipment and materials we used were the KickNet to find our qualitative data. We used the SerberNet to find our quantitative data as it covered an area of 960 centimeters squared. The aquarium, the buckets to put our sample collection in, small containers, the freshwater invertebrates ID booklet to help identify the species of mayflies we were collecting, the Leica microscopes, the Hobo, which is an electrode sensor that monitors conductivity and water temperature every 15 minutes. We got the air temperature from the Weather Channel, the forceps, petri dishes, waders, the coupler that connects the Hobo to the laptop, a computer, phones for pictures, alcohol for containment, and a micrometer to measure our mayflies from head to the end of the body.
So for the collection process, we would arrive between 08:15 and 08:30 at the Herring River. We'd put on our waders and set up a SerberNet in the middle of the river about 15 paces from the fish ladder. Meg would go and collect the Hobo and download the data onto her laptop and then return the Hobo to the river. We would record any observations we saw, such as the water height, the flow rate, air temperature that we got from the Weather Channel, and also any other things we noticed, such as on one day there was an increased amount of fish in the fish ladder. We would then take 3 KickNet samples. We would place the KickNet in the river about 15 paces and kick the ground about 5 times and then place them in a collection jar. We would do this 3 times before we left. After 30 minutes, we would collect the SerberNet and place it into a separate jar that we would label SerberNet, and then the other jar would get labeled KickNet. So when it came to organizing the samples, we would return to the Flanagan lab where we sorted the mayflies from the debris, such as sticks, leaves, anything that ended up in the kick net or the serber net. We kept the serber net and the kick net sample separate, and then once the debris was removed, the length of each mayfly was determined, and they were sorted into size categories, such as small, medium, large, and extra large. And this was measured in millimeters, and we will go into depth about how we decided each mayfly category would be sorted. The sizes were recorded, and the mayflies were put in an alcohol solution for preservation, just so we could study them further in the future.
Over the 10 weeks, we collected a total of 365 individual mayflies, sorted into 4 different categories. The small was 0 millimeters to 2.5 millimeters. Medium was 2.5 to 5. Large was 5 to 7.5, and extra large was 7.5 and above. On September 21st, we only used 1 sample jar. We had 7 small, 6 medium, 3 large, and no extra large, for a total of 16 that day. On September 28th, we also only used 1 sample jar. We had 13 small, 4 medium, 2 large, and no extra large, for a total of 19. On October 5th, for our kick net, we had 0 small, 2 medium, 3 large, and 0 extra large. For our serber net, we had 24 small, 18 medium, 3 large, and 3 extra large, for a total of 53. On October 12th, we didn't go out. On October 19th, we had in our kick net 0 small, 33 medium, 6 large, and 0 extra large. In our serber net, we had 28 small, 12 medium, 0 large, and 0 extra large, for a total of 89. On October 26th, we didn't go out. On November 2nd, in our kick net, we had 1 small, 5 medium, 3 large, and 0 extra large. In our serber net, we had 8 small, 34 medium, 4 large, and 0 extra large, for a total of 55. On November 9th, in our kick net, we had 7 small, 13 medium, 12 large, and 3 extra large. In our serber net, we had 8 small, 26 medium, 11 large, and 3 extra large. On November 16th, we had in our kick net 2 small, 5 medium, 2 large, and 1 extra large. And in our serber net, we had 1 small, 6 medium, 1 large, and 0 extra large. On our last day, November 23rd, in the kick net, we had 8 small, 12 medium, 6 large, and 1 extra large. And in our serber net, we had 1 small, 2 medium, 2 large, and 0 extra large, for a total of 32. After reviewing our data, we've concluded that the highest air temperature, water temperature, and conductivity recorded were 72 degrees Fahrenheit, 69 degrees Fahrenheit, and 108 PSU respectively. The lowest air temperature, water temperature, and conductivity recorded were 36 degrees Fahrenheit, 47 degrees Fahrenheit, and 72 PSU respectively. We also found that there is no correlation between the amount and the size of mayflies to either the water, air, or conductivity values, as the trend line of the mayflies is very inconsistent. As you can see in the photos below, mayflies are well adapted for swift flowing waters. Their bodies, head, and legs are flattened, which help reduce drag by forcing water over the organism.
As seen in the graph on the left, figure 1 talks about the mayfly sizes. There's no data for 1012 and 1026 because on the 12th there was a storm, and on the 26th it was deemed too cold to go out and collect data. On the 19th, there's a large spike in mayflies. We believe this is due to an increased number of fish in the river at the time, stirring up the mayflies since the fish eat the mayflies. There's really no correlation between sizes and the month. As you can see, it's not really linear. For figure 2, we recorded the water temperature, the conductivity, and the air temperature. Obviously, as the months progressed, the air and water temperature decreased at a pretty steady rate. The trend lines are in there. And the conductivity as well also decreased in a linear rate. For the discussion of data, in our findings, there was really no diversity of mayfly species within the Herring River. Only flathead mayflies were collected. We found other larvae, such as dragonfly larvae, as well as different worm and leech species, but for mayflies, we only found the flatheads. We did not observe any correlation between the water and air temperature and the number of mayflies in the water. The data was not linear. It was more of an arc. And then on the 19th, there was a large spike of mayflies collected. We believe this was due to the amount of smelt swimming downstream that day. The smelt feed on the mayflies as they head towards the ocean. So we believe that the mayfly were stirred up by the running of the smelt.
So what are we going to do next? We're going to continue the study into next semester like the rest of the groups. And we plan to keep protocol the same with the kick net placement, server net placement, amount of kick nets used and everything. And we'll continue to use 2 jars. I know in the first 2 sampling times we did not use 2 jars, so we're going to continue that, 1 for kick net and 1 for the server. But we do expect to see more mayflies next semester due to that time being the spawning season for mayflies, and with the amount of mayflies that we've encountered over this first sampling period, we do expect to see it at a much higher level due to the nice water quality and the good conductivity in the water. These are our citations. Are there any questions on the abundance and diversity of herring river mayflies?